It's a very good afternoon to everybody, and thanks very much indeed to our rector, Professor Matteo Lorito, and friends like Giorgio and Enzo to be here this afternoon. These are exciting times for robotics and AI. Often, if you read any article about AI, often is the case that the iconic image of AI is often a robot, is often a humanoid. So, if we want to dig into robotics and AI, AI is about intelligence. Of course, it's a tautology, but it's also about perception. Because, you know, we use ChatGPT nowadays, and so we exchange like some images, some videos, we exchange some text, we exchange some vocals. What is robotics? Robotics is defined as the intelligent connection of perception to action. So we have the two ingredients that we have in AI, namely intelligent cognition and perception. But what we have in robotics, we have the physical action. And in one word, this can be represented in terms of manipulation. What does an infant do in the first years of life? Infants, like 3-month-old, 6-month-old infants, they touch, they explore the world, they touch all the objects, and they try to grasp the object and bring them to their mouth. And the parents get worried. And why is this? Clearly, the level of intelligence of a 3-month-old child, infant, is not the same as like 2-3-year-old boy or girl, okay? So this is acquiring information about the world through the tactile perception. This is a very important concept which people in robotics and AI are studying. This is the concept of embodiment. So embodiment means that not only do we have a sort of neuronal cognitive intelligence, but also we have a sort of physical intelligence. And you read, and probably you saw this video, you know, it's about ChatGPT. Now, Sam Altman is the guru of ChatGPT. When OpenAI, which is the company that introduced ChatGPT, was founded like 3 years ago, there was a sort of statement that the challenge for OpenAI was merely on cognition and not on manipulation, because the physical intelligence was judged to be too complex to, you know, to tackle. In a time lapse of 2.5 years, you know, the scenarios changed. Why is that? Because this video shows the very first attempt to create a sort of generative AI, like ChatGPT, which would be able to support the physical action.
Hey, figure one, what do you see right now?
I see a red apple on a plate in the center of the table, a drying rack with cups and a plate, and you standing nearby with your hand on the table.
Great, can I have something to eat?
Sure thing.
Great. Can you explain why you did what you just did while you pick up this trash?
On it. So I gave you the apple because it's the only edible item I could provide you with from the table.
Great, so based on the scene right now, where do you think the dishes in front of you go next?
The dishes on the table, like that plate and cup, are likely to go into the drying rack next.
Great, can you put them there?
Of course.
All right, so how do you think you did?
I think I did pretty well. The apple found its new owner, the trash is gone, and the tableware is right where it belongs.
So why is this important? Because this is the very first attempt to create a physical generative AI without having mathematical models of the physical system. So is this going to impact our education, our approach to research? That's a big question for us. And because of this, together with a colleague, and a friend from University of Pisa, Antonio Bicchi, we published a comment in Nature like 3 years ago about the transition from the era of ICT, information and communication technology, to a new era, which is the era of interaction technology, where the acronym is intentionally made of 3 letters to disambiguate from IT, which would be like information technology, and it would be the same initial as interaction technology, but also to stress the importance of the physical action. And this is very much in line with the current program of Industry 5.0, or if you wish, Society 5.0, Agriculture 5.0, because besides the 2 buzzwords that our politicians use, which are resilience and sustainability, the most important issue is the upper vertex of this triangle, is the human at the center of the technology. So the transition from Industry 4.0 to Industry 5.0 is not only targeting at groups of users, but also to the individual user, to promote talent, to promote diversity. And in this scenario, communication also plays a very important role. We all think that thanks to 5G, our smartphones, our tablets, they go faster. But if you look at the triangle, the magical triangle of 5G, the most important vertex this time is the lower left vertex. This is the issue of latency, of the delay. No matter how fast our communication channel, our network will be, there will always be some delay. So the challenge is this latency, constant or not? Because if we can ensure that it's constant, then we can connect people and machines, robots and humans, not only locally, but also globally. And because of this, together with the transition from ICT to IoT, we are experiencing transition from the Internet of Things, data. So if you take an image, if you take a video, apart from the artistic component of the photographer, of the filmmaker that shot that video, basically the parameters identifying an image are absolute. Whereas the tactile perception is something very personal, very emotional, and it varies from one human to the other. So this is a transition from the Internet of Things to the Internet of Skills. So this time it's not only the data, it's not only the things, it's also the human skills, which are associated with the individual human. And thanks to the 5G technology, we'll be able to develop the concept of 5G-enabled tactile internet. So this was an intro to the issue of technology and technology transfer. Now, a few words about our Department of Electrical Engineering Information Technology. The year 2023 was a golden year, not only because Napoli was champion, we got the Scudetto, but also because University of Napoli Federico II got 12 departments, our rector emphasized yesterday, 12 departments out of 26 chosen by the Minister of University of Research, departments of excellence. And our department also confirmed for a second term, from 2018 to 2022 and 2023 to 2027. So these are the figures. I don't have time to go into all the details. Just want to mention that the large student population, so we have a big responsibility for our students because they will mark the future of our university and also of the impact on the society, and also, of course, the academies of the department. Now, on the interaction technology, we built the project which was awarded the Department of Excellence, and this is just one slide illustrating this project. And as you can see, the impact of interaction technology has a much wider scenario than robotics and AI, because it involves technologies for smart energy, for e-mobility in the next generation village. So this is the project that we are developing during these 5 years within our department. Now, one slide about my team, the Prisma team. So we are about 45 people, including all the postdocs, the PhDs, and the administrative and technical staff. We've been raising an average funding of 1.4 million euro a year, which is quite an impressive record for a team of this size. And 25 European projects funded in the last 18 years, including 2 ERC grants. We have partnership with a number of foreign institutions and companies, patents, awards, and so forth. And these are alphabetically ordered the 6 areas of research within our team. And beside the Prisma Lab, 8 years ago, we gave birth to a new venture, which is an interdepartmental center for advances in robotic surgery. This is the Icarus Center. And our team has also stamped 2 startups. One is Robotics, on inspection and maintenance of industrial plants and civil infrastructure. And the other one is Robots, which is another startup involved into development of soft robots for inspection and also for some medical application. This is a video illustrating in 1.5 minutes what we've been doing in the Prisma Lab. This is at Chesma, where is Mimo? The flying arena. This is very much in time with the Ribalta tonight, right? I made it on purpose, of course. So, a few words about the patents out of, these are only some of the patents. I have one slide with 4 patents in medical robotics, manipulation of medical robotics. There's a mini-invasive surgical tool. So the tool you see is one of the typical tools that you mount at the tip of a trocar of the Da Vinci system. So the idea is to provide more dexterity with a sort of 3 jaws hand, grasper and gripper for the surgeon to operate. Another patent is about a surgical tool for in-hand rolling, because as I was discussing with our friend from MIT, that will be talking later in the session, one of the issues for surgeons is suturing and anastomosis. This is a very tedious task after the surgery itself, and it requires a lot of stress and dexterity by the surgeon. So we have one patent about a new surgical tool which allows to achieve a sort of in-hand rolling to speed up the process and have less tiring on the surgeon hand. And also is another patent about miniature disposable tactile sensor, and one more about anthropomorphic prosthetic hand. The story about aerial robotics is quite funny. I remember in 2009, I got a phone call from a friend and colleague at Alma Mater University of Bologna, Lorenzo Marconi. Giuseppe knows him quite well. And Lorenzo called us because he wanted to get us involved in a project on aerial robotics, because we were good and experts in visual surveying. And the people in my team say, no, we know nothing. We're not aerospace engineering. We were discussing with Andrea earlier. We know nothing about aerodynamics. But the beauty of robotics is that it's very interdisciplinary. Believe it or not, since 2010, we got 8 projects, 8 European projects funded on aerial robotics at European level. You know, the acceptance rate is less than 5% nowadays. So there is no team in Europe that got so many projects. So it's, this is like really my keep the gradient philosophy. You have to challenge, you have to really tackle new challenges. And so was the case for aerial robotics. So 4 patents out of this work. One is a hybrid drone for ultrasonic pipe inspection, and this is quite an interesting system because one of the caveats of aerial robotics technology is autonomy. is batteries. So here, the idea is like to land on the pipe and spare and save energy. And so is the case for the drone for inspection and maintenance of high voltage power lines, in which we exploit the magnetic field of the power lines to get a sort of 24/7 working system just to get the energy and the automatic recharge in the station on the power lines. And there's also a robotic drone for non-destructive testing of civil structures. Think about the tragedy of the collapse of Morandi Bridge in Genoa 7 years ago. This was also because of lack of systematic inspection and maintenance. So why not to use these drones? And in fact, we have a cooperation with Eduardo Cosenza, who is a colleague in our university, and Ray Lewis. Ray Lewis is a network for all the labs in seismic engineering with Tecne, which is the development company of Autostrade, for the systematic inspection of viaducts, bridges, and tunnels, which is very critical for our country and, of course, for all countries. And another hybrid patent concerns an amphibious drone for deep water analysis, in which this is the concept of transforming machine, that robot that can fly, can land on the water, and then can take some samples underwater. And so we carried out some tests in the Gulf of Naples. There are also other robotics team at Tonina, which are worth mentioning. Actually, robotics is so pervasive, it's so transdisciplinary. Yesterday, we had a wonderful presentation by our friend and colleague, Cristina Mele, about the use of social robotics. And social assistive robotics is also the field of investigation of the Prisca team, which is led by Silvia Rossi. Now she's a full prof, right, in our department, in computer science. Tackling issues like human and context awareness, personalized service robotics, social assistive robotics, speech dialogue systems. And there is also an active group led by Professor Antonio Lanzotti in the Department of Industrial Engineering. This is the IDEAS labs, and they have a number of research areas which include additive manufacturing, fusion engineering and design, soft robotics, and sports engineering. Now, what is the impact in terms of technology transfer? Now, I have to say as an Italian that we are lacking a true entrepreneurial culture. 3 weeks ago, I was in an audition at Palazzo Chigi with the government, and I was called by the Golden Power Group. And the Golden Power just took me as an expert to have an opinion about the acquisition of Comau by some equity partners in the US. You probably remember that KUKA, which was the leading European company, robot manufacturers, was purchased by the Chinese 4 years ago. And so there is no major robotics manufacturer in Europe any longer because ABB is Swiss. And Comau was the last one. But nevertheless, I don't want to make any political speech here, but I was truly disappointed that the Golden Power Group allowed Stellantis to sell the technology to the US. Hopefully, some strategic technology within Comau, and I'm speaking about Yuvo. Yuvo is a company based in Pontedera. They have some excellence in making exoskeletons, wearable robotics. In my humble opinion, the exoskeletons will be the next pervasive technology. And it's a robotics technology after smartphones, because they're used by workers. They can be used by operators of civil protection. They can be used by tire surgeons, by anyone having to do a sort of physical work. So my humble hope is that those companies which are part of Comau will not be sold to the Americans. Of course, this is an Italo-American meeting, so it's a sort of issue. But of course, as an Italian, I'm sensitive to this. And nevertheless, a major initiative is RoboIT. RoboIT is the national pole for technology transfer in robotics, and this work started 3 years ago, thanks to CDP. CDP is a Cassa Deposito e Prestiti, is a major financial player, probably is the biggest one in Italy. And they launched this strategic initiative in robotics with a partner, which is Pariter Partner. It's a partner with a specific insight into robotics and AI. And there is a hub and spoke model. So the hub is Italian Institute of Technology. This was a political decision. And the three spokes are University of Verona, Scuola Sant'Anna in Pisa, and University of Naples, Federico II. And also, it's remarkable to say that as a sort of corporate partners, Leonardo Finmeccanica, which is the biggest group in our field, has been involved. It was mentioned by Mita during the presentation, Robosan, because like Vittorio Trifari is like the CEO of a company, and she got him involved. This is Robosan, which is the first proof of concept that has been funded coming from our university about a sanitizing robotic system, just to really have the inspection and sanification of all the environments, especially after the COVID pandemic. The final slide is devoted about, this is partially confidential because this is kind of nurturing ideas. We have one project together with some doctors at Ospedale Niguarda for the development of a local regional robot-assisted anesthesia. Because Ospedale Niguarda is the main hospital for Cortina 2026. And the idea is to have in Sondalo, which is a sort of twin hospital to Niguarda, the possibility of using through the network, through the 5G technology, a sort of remotely assisted anesthesia in case of any kind of accidents for the athletes in Cortina 2026. But my big baby is the new ERC grant, which I've received. This is the Synergy grant, and this is the Endotheranostics project. I believe very much into this revolutionary project. It's about developing a new technology, which we call theranostics technology. What is this word? I mean, it's of course an neologism. Theranostics means to do the therapy, the surgery, during the diagnosis. To have the possibility during a colonoscopy of inspecting the suspected mass, the polyp that you see there, and also to operate with a micro-robot with 2 arms and allowing the surgeon to excise and remove the polyp with safe oncological margin. This is a 6-year project that started July of this year, and our hope is that in the final year we'll have tests on human volunteers, and then we'll be able to create a startup company and to transfer this technology and probably to sell the technology to one of the big players, like for instance, I don't know, Cambridge or Medtronic or Siemens, Olympus. But our mission is really to fight the colorectal cancer. Believe it or not, in the US the data are slightly better, but in Europe, colorectal cancer has a mortality rate of 50%. And this is totally unacceptable for the level of mortality of the cancer itself. And you know why? Because it's diagnosed too late. Because people don't want to undergo screening because colonoscopy is perceived as sort of uncomfortable and undignified exam. So the idea is to create this less invasive method with this kind of robotics technology that can solve and excise the polyp in one shot. Thank you very much indeed for your kind attention.
Thank you.